structure, and that is mass spectrometry. First of all, let's discuss about some of the uses of mass spectrometry. Okay, so let's discuss about some of the uses related to that. First of all, first use is that it is basically used to measure the isotopic mass. It measures the isotopic mass. Like for example, if we have chlorine, we know one chlorine isotope is having the mass of 35 and other is having the mass of 37. Second, it is also used to measure the percentage abundance of isotope. Okay, so it is used to measure the percentage abundance of isotope. Like for example, chlorine 35, the existence of chlorine 35 is basically 75%, and that of chlorine 37 is basically 25%. So third use is that it tells us the molar mass of molecule or compound. So it also tells us the molar mass as well. And fourth thing is that it can also tell us about the structure of a compound. Structure of compound. Structure of compound means that it will help us to find out the number of bonds or even the functional group that is attached with the molecule. Okay, so in this way, we can utilize the mass spectrometry. Okay, so let's first of all, I just want to describe some kind of technical things related to mass spectrometry. That mass spectrometry, mass spectrometry only only works with gases sample, with gases sample. That means it doesn't work with solids or liquids. So it does not work with solid or liquid. ठीक है?
Okay.
And then we have that it works identify the positive gaseous ion molecular mass. So it identify the positive gaseous ion molecular mass. So important thing is that first it only works with gases sample, okay, and it is basically used to find out the positive gaseous ion molecular mass. ठीक है?
Okay.
And third thing is that how the ionization works actually. How the ionization works. And then after this, I'm going to explain you the diagram as well. How the ionization works. This is a question. So it works like, for example, we have this neon atom, and what is going to happen? There is an electron gun. The purpose of this electron gun is to is to do the bombardment of electrons in this atom. So it is going to bombard the electrons on it, or it is going to fire the electrons on this neon atom. And what is going to happen? An electron has been released from neon atom. So it is going to produce a neon ion. This is in gaseous form. Remember, it only works with gaseous states. This ion will also be in gaseous form with the release of one electron. Okay.
Okay.
So remember one thing. This is an atom. This is only an atom, but this uh, this mass spectrometry can also be worked with atoms, as this is an atom. It can also work with molecule, or it can also work with a compound as well. So it basically works in all three states. Okay. Now, what is going to happen? A gaseous, you can say, atom is going to enter from this particular place. Okay, this is vaporized sample. That means a gaseous, it can be a gaseous atom, can be a molecule, or can be a compound. So it is going to enter from this particular place, and you can see that this is an electron gun that is basically firing electrons. This is electron gun, and that is firing electrons on this gaseous sample. And what is going to happen? Electron has been released from this gaseous atom, molecule, or compound. And when electron has been released from there, then ions, they would be converted into ions. They would be converted into ions. And now, if you can see this properly, then what is basically happening around there? That these ion, this gaseous, basically you can say isotopes, they are different isotopes. They are going to split up because of the presence of this electromagnet. And why these ions are getting split up? These ions are getting split up on the basis of their, you can say, masses and their charges. We are not going to discuss about their charges now. We will only be discussing about their masses. So what is going to happen around there? Because of this electromagnet, you can see this is our first line. I'm going to mark it with red color. That has been deflected at this place. And you can see the one which has been deflected at this place, at the top. Which one is basically deflecting more and which one is deflecting less? So this is deflecting less. You can see that this is deflecting less. So the important thing for us to understand here, the one which is deflecting less would be having a heavier mass. You must need to remember this thing. The one which is deflecting less would be having a heavier mass. And one which is deflecting more, this is deflecting more. So it would be having less mass. Okay. So this is basically deflecting less, so it is having a heavier mass. And this is deflecting more, so it is having a less mass. Now, we are basically not interested in this one. We are not interested in this one right now, which is basically moving straight. So we are only considering this one, which is having a heavier mass, and one which is having less mass. Is that clear, Sultan?
Yeah.
Okay. So now let's move further towards the next part. So now, okay, you can see this is a mass spectrometry chart for molybdenum, for molybdenum. You know, molybdenum is basically a metal. And now, the thing that I want to explain you before going towards it, I just want to describe you one important thing, that mass spectrum that are basically used for two types. The one is for elements which exist in atomic form. So elements which exist in atomic form. Okay. The one which exists in atomic form, that they can be either metals or they can be either be noble gases. Is that clear? So they can either be metals or can either be noble gases. And the condition for them is that, this condition is very important, that their number of isotopes would equal to number of peaks. Okay? So
Okay.
number of isotopes is basically equal to number of peaks. How it is going to happen? Let me show you. If you if you come towards this one, there are how many peaks? If you can see that there are 1, 2, 3, 4, 5, 6, 7. As we know that molybdenum is basically a metal. Molybdenum is a metal, and we have studied this thing that their number of isotopes is equal to number of peaks. So there are 7 peaks. How many peaks are there? 7 peaks. So that means how many isotopes would be having this molybdenum? 7 isotopes. Is that clear, Sultan?
Yeah.
Okay. So now let's move towards mass spectrometry. Now, the other type of mass spectrum is for molecule or a compound. So, for molecule or compound, so what is going to happen? We know that molecule, which is chlorine, which is in 75%, and we know the it is basically 35 chlorine 35, we know it is in 75%. And the other isotope of chlorine, which is 37, and we know it exists in 25%. So the question arises, we know that chlorine, this exists in Cl2 form. So this is basically a molecule. The major question arises here, that how many peaks chlorine would be having? Chlorine would be having. So they would be, mm, right now, I'm not having the peaks of chlorine. Okay, just let me find it from. So you can see that chlorine molecule is having five peaks: one, two, three, four, and five. So you can see that this is very unusual. Why it is having five peaks? So let's find out the answer for that. When chlorine gas is ionized, Cl2 gas is ionized, then what is going to happen? For example, first molecule that chlorine is having, we know that it has two isotopes, Cl35, Cl37. So when this molecule which is having 35 and other is also having Cl35, we know it has this electron, and this one is having this electron. Basically both of them are sharing electron. So when electron gun is basically doing the bombardment of electrons, then what is going to happen? A bond is going to break. A bond is going to break, and this electron has been removed. If this electron has been removed, then we know this chlorine has become a radical, which is chlorine 35 with a radical on it. So this is a free radical. But with second atom, you have seen that it has become an ion because this electron has been lost. So this has become an ion like this with the loss of electron. One important thing that I want to tell you, mass spectrometry doesn't find the mass of this radical. So it is not going to find the mass of this radical, only the mass of this ion is going to be found. Is that clear? Yes, Sultan, is that clear?
Yes.
And the peak that you have seen over here is basically the peak of this ion. Now, let's look at the second condition. This is our first condition. Let's move towards second condition, and that is this Cl35. One electron is here, and the other electron is at this place, and we know this is Cl37. And if we are bombarding the electrons, then what is going to happen around here? This electron has been removed. So a bond will break, and now this electron has been removed, and this would become a radical. Is that clear, Sultan?
Yeah.
So it is having a positive charge like this with the loss of electron, and now it is not going to find the mass of this free radical. It is only going to find the mass of this uh, ion. And that is for this one. Is that clear?
Yeah.
Okay. So then let's move further towards the third condition. And that would be third condition. The first condition is when two would be having same masses. And the second condition is that when there is one atom of 35 and other atom of 37. And now both are having the mass which is 37. And when we are bombarding electrons, then what is going to happen? This is also Cl37. Then what is going to happen? This electron will be lost and the bond will break. So it is going to form a free radical, and second is going to form a ion. Oh, that is ion with a loss of electrons. So it is not going to find the mass of this free radical. It is only going to find the mass of this ion. So second thing that I just want to tell you, that this is the reason why it is having these two peaks of 35 and 37. But this peak also shows us, because the graph has been plotted between this mass to charge ratio. This is basically mass to charge ratio, and it has been plotted versus relative abundance. This is a relative abundance. Okay. So this relative abundance show that chlorine 35 basically exists in maximum quantity. Is that clear? In Earth
Yeah.
crust, its existence is in maximum quantity, because we also know that chlorine 35 exists in 75% and that only exists in 25%. Now, the question remains that why we are having this peak of 70, 72, and 74. Let's discuss the reason right now. So there is fourth condition in which there is chlorine 35 and it has been bonded with another chlorine 35. And now, what is going to happen? We are again bombarding it with electron gun. So now, what will happen? The condition would be this, that now these two atoms, their outermost shell, because we know that this electron is basically present in the outermost shell. Now, electron is not going to be removed from outermost shell. Very important thing that I want to discuss here, that in this condition, electron will not be removed from outermost shell. Instead, what is going to happen here? The electron would remove from inner shell, from inner shells. Is that clear? So when
Yeah.
electron would be removed from inner shell, then what is going to happen? This bond will not break. The bond will not break. And chlorine would exist as a molecule with a molecular mass of 70 and a positive charge, because it has lost the electron. It has lost the electron. So it is going to have a positive charge with the loss of electron. Sultan, is that clear?
Yeah.
And you can see that here we are having this peak of 70. That is because of the reason I have told you. Okay. So now let's look at some other conditions regarding that. And that is Cl35, and that is Cl37. Okay. So what is going to happen? Again, the same condition would occur, that electron would be removed from innermost shell and it is not removed from the valence shell. So the formula would become like this. And now 35 plus 37 is 72 with the positive charge, as electron has been removed from inner shell with the release of electron like this. And sixth condition shows us that and for this 72, I just want to show you its peak as well. So this is basically the peak. Okay. So now
Okay.
we are having this 37. Again, this electron Cl now is having 37. So again, we are bombarding electrons, but electron is removed from inner shell. So it would become 74 as 37, and 37 would become 74 with a loss of electron like this. And that is why we are having the peak of this 74. I hope this point is clear to you.
Yeah.
And now Cl2 positive, Cl2 uh, positive, this is 70, this is 72, and this is 7 Cl2 positive, which is having 74. And the ratio between their abundance would be 9 ratio 6 ratio 1. Just write it down. I'm going to tell it the reason to you later. Okay.
Okay.
Now, let's move towards the next one, and that is basically let's discuss the mass spectrum of pentane. We just know that pentane is CH3, CH2, 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 and CH3. This is basically the molecule of pentane. Okay, so let's just draw its structure as well. So, first of all, the important thing for you to understand is that the peak, which is basically present on the right hand side, on the most right hand side in this molecule, this is basically pentane, and the peak which is present on the most right hand side, that basically represents the peak of molecular ion. That would be of pentane, C5H12 positive, okay? Because it has lost an ion, lost an electron, so it has become positive. And remember the peak on the most right side peak, that shows the mass of molecular ion. Is that clear?
Yeah.
So, like for example, if you can see its molecular mass 12 multiplied by 5 plus 12, and that would become 72. So, now what is going to happen? And now we have to find out that how does the remaining peaks comes. So, if you can see its structure, that is CH3, CH2, 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 and CH3. So, first of all, if we are going to bombard the electrons, then what is going to happen? That we know it is having this electron, this electron. So, this bond is going to break, And what is going to happen around there, that CH3 positive ion would be created. Okay. And how does it create it? Because electron from here has been removed. This electron would remain there. So it has become a radical. It would become a radical. And let's write the radical, that is C4. And how many hydrogen? 5, 7, 9. H9 dot would be there. So this represents a radical, a free radical. Is that clear? With the
Yeah.
loss of electron. So this is basically its structure. And if you can see this CH3 positive ion, so its molecular mass would be 15. So this has been represented by this peak. Is that clear?
Yeah.
If we look further towards other peaks, then we would see, like, let's look at this 57. How does it comes from? So if the structure would remain the same like this, and now if this electron has been removed, then what is going to happen? CH3 would become a radical like this, and this would, as it has lost the electron, now it has become an ion. How it has become an ion? C4H9 with a positive charge on it with a loss of electron. So the molecular mass of this one would be, how much would be the molecular mass? 12 into 4, that is 48. 48 plus 9, that is 57. Okay. If that is 57, then what does it means? That this peak is basically represented by this C4H9 positive. Is that clear, Sultan?
Yeah.
Okay. So now let's discuss about this peak. In the diagram, he's saying that this peak is basically called as a base peak. And why we are calling this one as a base peak, let's find out the reason regarding that. We have a molecule that is CH3, CH2, and then we have CH2, then we have CH2, CH3. If we see that they both are having the molecular mass of 29, and this is the only one that is having a mass of 49. Sorry, 43. This is 43.